When async and await are used in C#, the compiler and runtime work together to transform a seemingly sequential method into a highly efficient, non-blocking asynchronous operation. Although the code looks simple and linear to the developer, a significant amount of processing happens internally to ensure scalability and responsiveness. When the C# compiler encounters an async method, it does not execute the method differently at runtime by itself. Instead, the compiler rewrites the method into a state machine. This state machine tracks the execution progress of the method so it can pause and resume execution at specific points. Every await keyword marks a potential suspension point in this state machine. When the method starts executing, it runs synchronously until it reaches the first await. If the awaited operation, such as a database call, file I/O, or HTTP request, is already completed, execution continues immediately without suspension. However, if the operation is not completed, the state machine captures the current execution state, including local variables and the current instruction position. At this moment, the method returns control to the caller without blocking the thread. The awaited operation typically runs on a separate thread or uses I/O completion mechanisms provided by the operating system. Importantly, async/await does not create new threads by default. Instead, it relies on non-blocking APIs and the .NET thread pool. This allows the original thread, for example, a web request thread, to be released back to the thread pool and used for other work. Once the awaited operation completes, it signals the runtime through a continuation. The continuation tells the state machine to resume execution from where it left off. If a synchronization context exists, such as in UI applications or ASP.NET prior to core, the continuation is posted back to the original context to ensure thread affinity. In ASP.NET Core, which does not use a synchronization context, the continuation may resume on any available thread pool thread. Exception handling is also managed by the state machine. If an exception occurs in the awaited task, it is captured and rethrown at the await point, preserving a logical flow of error handling using standard try-catch blocks. Similarly, return values are wrapped inside a task or task, representing the eventual completion of the method. In essence, async and await convert blocking code into a cooperative, event-driven execution model. This design enables applications to handle thousands of concurrent operations efficiently,